Okay, so this is proofs again. Yay! We're going to do proving triangles are similar. And so if you remember with similar, it means that the angles are congruent, but not necessarily the sides. So if they are similar, that means the angles are congruent and the sides have proportionality or have scale factor, which means that they all have the same scale factor. So with proving triangles are similar, there's a few ways we can do it, and it's angle, angle, side, 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 and side, angle, side. So we're going to take a look at angle, angle. So this stuff's going to be pretty easy for you guys because you guys already understand all this stuff. But side, side, side's a little tedious, but not too bad. So let's take a look at this first one. So of course, you know I like to extend my parallel lines, and you can see that I have parallel lines right here. And so if I have parallel lines right there, I can use either one of these lines as my transversal. So let's just say I use that one, which means I have this angle and this angle, which is alternate interior. And all I'm really looking for is trying to find two angles that are congruent. So I've got alternate interiors there. And then if I wanted to, I could use this transversal and then get alternate interiors here. That would also give me angle, angle. And then of course, we have a third one where we could do the vertical angles, right? So really, you just need to get two angles that are congruent. So therefore, this is yes. And then if it is, you need to do your similarity statement. So triangle DCE is similar to triangle FGE. Right, let's move on to the next one. So the next one, whenever you have parallel lines, remember we always use parallel lines. So if I extend my parallel lines and then use my transversals, so here's my transversal, I've got this angle and this angle. And then if I extend the other transversal, this transversal, that gives me this angle and this angle. So, and if you look, what we've got here is we've got two triangles. We got this great big humongous triangle, and then we've got this little triangle. So that's the two triangles we're trying to prove. Another thing we could have used if we wanted to is they're sharing an angle. So we could have used that. So this also has angle, angle. So again, it's a yes, and then you put your similarity statement. So QLP is similar to triangle MLN. Right, cruising right along, let's go to the next one. So the next one, what we need to do is we need to do a little math. Okay, so here we're trying to figure out if we've got two angles. Well, of course we've got one right here. They're both 90-degree. And so we have to do, remember, every single triangle, the sum of the interior angles of every single triangle is, I can't believe you guys didn't say it, it's 180. Okay, so anyways, 180 minus 90, of course it's 90, and then 90 minus 39, which gives me this one here is 51, that means this one's 39, therefore we've got another angle, right? So therefore this is a yes, and we can do our statement, which is SYE is similar to triangle WCH. All right, moving right along, we're going to go to the next one. Of course, the sum of the interior angles of every single triangle is, well, I don't know if you did it, but I hope so, 180. So 180 minus 68 minus 54, which means this is 58, and this is 180 minus 68 minus 63, which I'm pretty sure you can already tell this one is not going to work because it only has one angle that is the same. So therefore, no. All right, let's move on to the next one, number 5. And here we need to look at, let's look at this big triangle first right here. So 180 minus 25 minus 67, which gave me, this is, get back to my pen, 88. And then if we go to the next one, to that little one, to this one, we go 180 minus 91 minus 67, and you get 22. Oh, put it back on Ben. Got it. So therefore, this is a no. It does not have two angles that are the same. Now, this next one, we've got angles here, and we have vertical angles. So therefore, this is a, whoops, that's supposed to be a yes. This is a yes, and it is triangle PXQ is similar to triangle ZXY. All right, moving right along. So this one is side, side, side. With side, 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 you have to prove that, that your proportions work. So we need to look at the proportions. So one of the things you need to take a look at is look at the smallest side. So smallest side and smallest side. So therefore, that's a proportion. So small over 14. And then we'll go to the middle side. So this one is 13.5 and this one's 21. So therefore we'll go there. Small over big. And then the last one is the biggest side, which is 27 and 42. That's how you set up your ratios. Now, if we set up these ratios, what we're going to find out is that they all are the same thing. Therefore, this is a yes. And all you do is plug it in your calculator. And we do our statement. KNR is similar to triangle DES. All right, so let's move over to the next one. And again, we've got a small triangle inside of a big triangle. And so we have to set up our proportions. So if we're going to do small again, one of the things we need to think about here is this whole side here. So the whole side is 21. This whole side is 28 because you're looking at small to big. So I'm going to go the smallest side. So the smallest side of the little one is, oops, the smallest side of the little one is 15, and the smallest side of the big one is 21. So we're going to go 15 over 21. We're just setting up our similarity statements. And then the middle size of the little one, let's see, 15, 20, 40 is 20. So we need to go to the middle size of the big one. So we got 21, 28, and 56. So it's 28. So we've got 20 over 28. And then finally, we want to do the biggest side. So the biggest side of the little one is here, and the biggest side of the big one is there. So 40 over 56. When you plug these in, these are all equal to each other. Therefore, this is a yes, they are similar. And our similarity statement is UWY is similar to triangle VWX. Cool. All right, let's cruise on. Let me zoom in a bit. And we're going to try these out. So let's take a look at our smallest side. So my smallest side on this big one is here, and the smallest side on the little one is there. So therefore, I'm going to do big over little. Let's go here. The middle side is 12. The middle size is 7. So 12 over 7. Stay consistent. We're doing big over small. All right, and then our last one, the biggest side is 16 and the biggest side is 10. So you're going to plug it in your calculator and see if those are equal. And this one, it turns out all three of those are not equal. Therefore, they don't have the same scale factor. That's what we're trying to find, is the scale factor. So this is a big no. So you want to try to see if all three of these are the exact same thing. And actually, you can kind of see 5 to 3, and I can't really reduce 12 to 7, right? I can reduce 16 to 10, which would be 8 over 5. So none of these are the same. It's totally wrong. All right, let's go to the next one. So I'm going to find the smallest side. The smallest side of this triangle and the smallest side of the other one is here. So therefore I'm going to go 5 over 18. Okay, now let me go to the middle side. 12, and the middle side here is 43.2. So 12 over 43.2. And then we'll do the biggest. And so the biggest side is 15, and the biggest side is 54. So 15 over 54. And with this one, when you do all three of these proportions, they're actually the exact same thing. So this works, therefore this is a yes. And my statement is PAR is similar to triangle YTR. All right, next one. Again, we're going to do the same thing. The smallest, and then the smallest over here. So 8 over, is that a 4 or 0.4? Oh, it didn't print very well. It's actually a 14.4. So this should actually be 14.4. Okay, I was looking at that like, what the heck? Okay, so equals, now I'm going to go for the middle one. The middle one is 15. The middle one is 27. So 15 over 27. And then the largest one, and the largest is 17, and the largest is 30.6. So 17 over 30.6. When I plug all of these in my calculator, they actually all equal the same thing. Therefore, it is the exact same scale factor. So this is a yes. And my triangle similarity statement is ZYX is similar to triangle RWV. All right, last one in this situation. So let's look at, we've got a great big triangle, and we have a little triangle. So that's how we're going to set this up. So let's go for the, oh wait, we're going to have to add these up. So this whole big side is 20. And that one's already done, and the other one's done for us. Okay, cool. So let's go for the smallest. So let's see, 2016. So 16 is the smallest, and then the smallest side here is 6. So 16 big over small. Now the middle number, let's see, 20 or 24, so 20. And then the middle number here is 8. So 20 over 8. And then finally, we'll do the biggest number, which is 24 and 9. So 24 over 9. When you plug this in your calculator, you're going to find out that these are all different ratios. So this is a big no. All right, last one. So with angle, you didn't have to do any calculations. You just had to find two angles that they were congruent in both triangles. Inside, side, you have to do the most work because you have to compare all three sides. Inside angle side, you just need an angle, and then you need to compare the two sides that contain the angle. So if you look, we've got our angle, and then we've got sides. So let's go with the smallest side first. So 6 and 24. So 6 over 24. And we want to see if that's equal to the other side, which is, oops, I'll change it, 12 and 48. So 12 over 48. And if you do it, yes, they're the exact same scale factor. So this is a yes. And our triangle similarity statement is SER is similar to triangle GEF. Okay, next one. Obviously, we do have an angle. We've got this angle here. But the problem is that's not side angle side, because if you look, the angle is not contained between the two sides. So what we really needed is we needed our angle to be here where it is contained between our two sides. So because that's not, therefore this is a no, because the angle is not included in our sides. All right, let's go to the next one. Here we go. We've got parallel lines again. So here's a parallel line and here's a parallel line. This is our transversal. So we have this angle and this angle that are congruent. They're corresponding angles. And you'll notice that the side angle side. So the sides contain that angle, which means we're going to go ahead and set it up. So I'm going to do the smallest, which is a 36 here and a 22 here. So 36 over 22, and we want to see if that is equal to the next one, which is 54 and 33. 54 over 33. When you plug that in your calculator, it actually works. So therefore, this is a yes. And we need to do our similarity statement. So triangle CMP is similar to triangle RPQ. All right, moving along. Here, the angle is contained between the two sides. So let's check out our proportions and make sure the proportions work. So I'm going to do the smallest, 45 and 31.5. So 45 over 31.5 is equal to, and then the next one, which is 50 and 35. 50 over 35. When you plug this in your calculator, it works. And then we do our similar statement. EGF is similar to triangle JHK. All right, let's move to the last two. So first thing I need is I need two angles. Or I'm sorry, not two angles. First thing I need is one angle, and it has to be contained between the sides. So I've got this big triangle here, and I've got this little triangle here, and you'll notice this angle right here is what they share. So therefore, this is their angle. And then we need to do our big angle side, which is 45, and our big angle side here, which is, let's see, what is it? 28, 38, 20. Golly, stumped myself. That's 42. All right, so here we go. We're going to go look at the little side of the little one, which is 14, and the little side of the big one. So 14 over 42 is equal to, and now we're going to look at the other side of the other one, so 15 to 45. And when you plug those in, it turns out that they work. And so because they work, that means that these are similar, and we get triangle QWR is similar to triangle SWZ. Okay, last but not least, if you'll notice, we've got a big triangle and we've got a little triangle. And what you should see is they both share this angle. So we need the length of this whole side, which is 39 for the big one, and then the length of this side, which is 34. And let's go ahead and set up our proportions. So we'll go ahead and do the smallest one, so 27 and 34. 27 over 34 is equal to, and let's do the next one. So we're going to do 30 and 39. 30 over 39. And in this case, they do not work, so therefore it's a big no. Okay, so the one thing that I want to tell you guys is when you do your homework, which is what you're going to do next, okay, you're going to get together with partners or you can work together, whatever. You know where my glue is. My glue is right there underneath where the hand sanitizer is. There's glue sticks. There's scissors there. You're going to go through and you're going to do this puzzle thing. And you're going to glue it on there. And here's the biggest thing of it all. Do not take a picture of that and put it in Google Classroom without work. All right, you must show your work. So for side, 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 you need to have three comparisons. So AB compared to CD compared to EF. For side angle side, you need to have two comparisons to show that the scale factors work. For angle angle, you just have to show me which two angles they have congruent. All right, guys, good luck.